Hi class, how are you today? That's factorable. The learning target for today is to be able to solve quadratic equations by factoring. So we know how to factor quadratic expressions, and now we are going to solve equations by using that method. For the scale, you're a 3 if you can solve quadratic equations by factoring. You're a 2 if you can factor quadratic expressions. So that's what we recently learned how to do. You're a 1 if you can factor quadratic expressions when a equals 1. So that's the more basic quadratic expressions that you learned how to factor. And you're a 0 if you cannot factor quadratic expressions when a equals 1. Let's get started. All right, first, let's deal with an equation that's already in factored form. And we're going to use what's called the zero product property. What that means is if you have two things, in this case binomials, that are multiplying by each other and they equal 0, then one of them has to be 0. Either the first one has to be 0 or the second one has to be 0. Or maybe both of them are 0. So what we need to do is solve for the case that either of them are 0. So we need to split this into two equations now, and we're going to get two possible answers. So we have 2x minus 5, and we're going to make that equal 0. And then we're going to have x plus 6, and then have that equal 0. So two separate equations. And in the first one, solve it like you normally would. Add 5 to both sides. 2x equals 5. Divide by 2. And x equals 5 over 2. If you want to change that to 2.5, that's perfectly fine. I like keeping them in fraction form, but I will take either answer. And for the second one, subtract 6 from both sides, and we get x equals negative 6. So we have two possible answers here. X equals 5 over 2, but also x equals negative 6. Technically, you would say it equals one or the other. But you do need both answers to be correct. All right, now we're going to actually solve quadratic equations. What we just did was what the end portion's going to be. And now the only difference is we're going to start by doing what we've been doing and factor first, get it into factored form, and then do what we just did with the zero product property. So in the first one, a equals 0, so that makes it super nice. So we're going to say, okay, factor pairs of 20 that add to 9. Just as a quick review on how to do these, we've got 1 times 20, 2 times 10, 4 times 5. Those are all the factor pairs of 20, and we need to figure out which one adds to 9. So, well, 4 plus 5 equals 9, so that's the one we're going to use. So we'll have x plus 4 times x plus 5, and that all equals 0. And now we go to the zero product property. So we split them into two separate equations now. We're going to have x plus 4 equals 0 and x plus 5 equals 0. Subtract 4 from both sides. X equals negative 4. Subtract 5 from both sides, x equals negative 5. So we say x equals negative 4 or x equals negative 5. And again, we do need both answers. And if you plugged those numbers back into the equation up top, substituted them in for x, you would find that they do indeed equal 0. So that's a good way to check your work. On the second one, this one is going to be a little bit more tricky. And remember, I taught a couple different ways on how to solve these, but usually I find most people understand the grouping method better, so I'm just going to do the grouping method here. If you know how to do the other method and you want to do it that way, that's perfectly fine. But for this video, I'm going to use the grouping method. So 6 times 20 is 120. And I'm not going to write all the factor pairs here, the two numbers that multiply to 120. There's a lot of them. But let's just figure out which ones will add to negative 23. So it's negative, so we know it's going to be two negatives because we had a plus here and a minus here. The plus tells us it's going to be the same sign, and that negative tells us they're going to both be negative. So if you go through all the factor pairs, you eventually will find negative 8 and negative 15 multiply to 120, but add to negative 23. So then we're going to rewrite this equation, 6y squared minus 8y minus 15y plus 20 equals 0. And then we group. So group the first set. Remember, change this to a plus, and then inside the parentheses, change that to a negative, because we always have to have a plus in the middle. And now find the GCF, find the greatest common factor of each set. The GCF of the first set is going to be 2y, and left on the inside is 3y minus 4. And then the GCF on the second, we've got the negative in front, so we need to factor out a negative, but specifically a negative 5. And what's left on the inside is 3y minus 4. And this all still equals 0. And remember, these two have to be the same in order for this to work. So now we factor out the 3y minus 4. And what's left is 2y minus 5. And it still all equals 0. And now we're at the zero product property. So 3y minus 4 equals 0, and 2y minus 5 equals 0. Add 4 to both sides. Gives you 3y equals 4. Divide by 3. Y equals 4/3. That turns into a repeating decimal. I definitely don't want any rounded numbers, so I would prefer you just leave it like that. And for the other one, add 5 to both sides. 2y equals 5, divide by 2. And y equals 5/2. So we have answers of y equals 4/3 or y equals 5/2. Now these aren't very nice answers, but they are the answers to these equations. Alright, so now let's just solve some more of these. More examples, they look a little bit different. Let's try these. So, in this case, they don't equal 0. So, that's where we need to start. We need to start by making the entire right side 0. So, we move everything over. How do we move everything over? We add or subtract from one side to the other. So let's subtract 15x from both sides. And remember, we've got x squared and x. Those are different, so we can't combine them. So this is going to be 5x squared minus 15x equals 0. Now, in this one, always, if you can, start by factoring out a GCF. If you can factor out a GCF, you're going to want to. So, factor out a GCF, we've got 5x, and what's left is x minus 3, and it all still equals 0. Well, there's no more factoring to do now because we factored out GCF, and now we don't have any squared terms left. So now we use the zero product property. And in the first equation, it's just going to be simple 5x equals 0. And the second one's going to be x minus 3 equals 0. On the left one, divide both sides by 5, and you get x equals 0, because 0 divided by anything is 0. And in the right one, add 3 to both sides, and we're going to get x equals 3. So we have x equals 0 or x equals 3. And on the right one, well, we're going to start by adding 48x to both sides. There are no like terms on the left side for that to add with, so it's just going to be straight 16x squared plus 48x plus 36 equals 0. And now we can factor out a GCF. So we can factor out 4. So we've got 4 times 4x squared plus 12x plus 9 all equals 0. Now we can do what we did in the previous problem a couple problems ago and do 4 times 9 is 36 and find which factors of 36 add to 12. Or you can notice this might be a perfect square trinomial because 4x squared and 9 are perfect squares. So let's just check. Well, 4x squared is the same thing as 2x all squared, and 9 is the same thing as 3 squared. So then 12x should be 2 times 2x times 3. Two times 2x is 4x, times 3 is 12x. That works. Check mark. So we can just write this as the 4 goes on the outside, because we're just dropping it down, and then 2x plus 3 all squared equals 0. And you might look at this and be confused on, well, how do we split this into 2 problems? And that part may seem like it's confusing. And there's a couple different ways to break it down. And so technically we could turn this into 3 problems because the same thing is 4 times 2x plus 3 times 2x plus 3 all equals 0. So we split it into 3 problems. 4 equals 0, 2x plus 3 equals 0, 2x plus 3 equals 0. Well, 4 equals 0, that's not true. That just doesn't work. 2x plus 3, subtract 3 from both sides, and you get 2x equals negative 3, divide by 2, and you get x equals negative 3 over 2. And if you notice, this is the same thing. So if we do the same thing again, we'd get 2x equals negative 3 divided by 2, and x equals negative 3 over 2 again. And so we turned it into 3 different equations, but we only got one answer. If you end up with a perfect square trinomial, you're always going to get one answer. Even though we factored out a 4, that 4 by itself can never equal 0, and then 2x plus 3 squared, 2x plus 3 is just happening twice. So it's one answer that happens twice. And so in this case, we only have one answer. All right, now time for the sponge. Solve each quadratic equation by factoring. So do what we did in this video and factor both, and then use the zero product property to solve for x. And there's probably going to be 2 answers. All right, that's it for this lesson. Once again, please make sure to take notes on the entire lesson. Take a picture of everything, including the sponge activity. Submit it all to Google Classroom, and have a good night.